Okay, so when we double distribute here, x times x should have given you x squared. X times negative 5 should give you negative 5x. Then when I multiply the 3 times the x, I'm going to get a positive 3x. A 3 times negative 5, I get a negative 15. Now, what you have to do here is you have to remember that the two middle terms are going to be your like terms, and you are going to combine your like terms. So I'm going to get x squared minus 2x minus 15. This is now called a trinomial. We are now going to factor these trinomials. When I factor the trinomial, it will go back and give us two binomials. Okay? Is everybody with me? All right. Now, when we check, after we factor, and I'm going to teach you how to factor in a second, after we factor and we check, we're only really going to be worried or concerned about the middle term. You'll see why. And we use this thing called, and I want you to write it over here, we're going to use this thing called big smile, little smile, and I'll show you it over here, write it down, and I'll show it to you what it is, to check the middle term. In that video that we just saw, he was actually showing you that. He was calling it the outer and the inner instead of big smile, little smile. And so this is what it looks like. You multiply the outer terms together to get negative 5x. Then you multiply the inner terms together to get a positive 3x. So basically you're just checking to make sure that you picked the right numbers that are going to give you the negative 2x. You'll see we'll do a bunch of them in a second. Okay? So this is how we check. This is what we're going to use for our check. Now, when we check it, could we do all this? Could we do the double distributive and do all, multiply everything together? Sure. This is, like I said, just a shortcut. So here, when we factor, we take the first term, we use two parentheses, and the first term is the product of the first binomial positions. The last term is the product of the second binomial positions. And the middle term is a combination, is the sum of the outer and the inner. That's that big smile, little smile thing I was talking about. All right, so we made this little chart here. And we are going to the first thing we have to do when we factor is we have to figure out what the signs are going to be. So when I factor a trinomial, I always have two sets of parentheses. Okay? These are some generic forms of trinomials that have letters in them, not numbers. What we do first is we look, make some little eyeballs here. We look first at the second term or the last term. And if it is positive, this is what they were trying to tell you in the video. We can watch it again afterwards if you want. Yeah. If it's positive, that means signs are the same. What does that mean? That means they're either going to be both pluses or both minuses. Okay? So how do I know if they're both pluses? After I look at the first or the second term, I go back and look at the first sign. The first sign, if it's positive, they're both going to be positive. If the first sign's negative, then they're both going to be negative. Okay? Does everybody understand what I'm saying? So look at the second sign first. If it's positive, signs are the same, either both plus or both minus. Okay? Now, if the second sign is minus, then our signs are going to be different. Just abbreviate the word different here. What does that mean? That means one's going to be plus, one's going to be minus. I'm not sure which one is going to be which. I just have to check it. And they said that in the song there too, how to check it. We're going to do the big smile, little smile to check to make sure that we have the signs right. And here's just exactly what I said in words down here. It says, set up two parentheses, determine the signs. In the first position, put the factors of the first term, and the second position, put the factors of the last term. Check by multiplying the binomials. But now we are going to check by using this thing. I don't know if Ms. Shug called it big smile, little smile.
Yes, she did.
She did. Okay. So
the thing was with that is that she did. I remember her using it as a check. Oh.
yeah, she did. Yeah. Well, it just means that it can go either into the plus could either be in the first position or it could be in the second position. If they're different, you have to check to make sure where the sign goes correctly. Nope. This, you got to look over here. See how this is a minus and this is a minus? This means signs are different. This means you got to look here first. This means signs are the same. You'll see when we do some examples. Okay. All right, let's look on the next page for the examples. All right, so here, let's look at this. Again, we're going to look at the second sign first. This means the signs are going to be same, right? Plus means same. What about this one? Plus means same. This one's a negative. This is going to be different. So let's set up our two parentheses. Now, all of these, when you factor any trinomial, you're always going to have two parentheses. So we can go ahead and just write our double set of parentheses in every problem here. Okay? Now, you okay, Colin? Okay, go ahead. You want to run to the nurse? Okay. Okay. So signs are the same. I'm going to look at my first, in my first position here. That's positive. That means both signs are going to be positive. This is a negative. That means they're both going to be negative. This, when I looked here, this was a negative sign, meaning different. That means one's going to be a plus, one's going to be a minus. Okay? Okay, the next thing you're going to do is you're going to make a factor chart. I'm going to look at my I look at my first term, x squared, and I say, okay, what multiplies to give me x squared? X times x. Then I look at my last term, 12, and I make a little factor chart here. 12, all the things that multiply to give me 12. 1 times 12, 2 times 6, 3 times 4. Okay? And also 4 times 3. When you repeat yourself, you know you have found all the factors, everything that multiplied to give me 12. Now I'm going to say, all right, well, what is going to give me a 7 in the middle? 1, 12, 2, 6, 3, 4, or 4, 3. 3 and 4 or 4, it doesn't matter, either one. So now, I could double distribute this and check it to see if I get that back again. But the easier thing to do is just to do my little smile, big smile. I'm going to check to see if I get my 3x or 7x in the middle. 3 times x is 3x. 4 times x is 4x. When I add together 3x plus 4x, when I combine them, remember that's our like terms in the middle, I'm going to get 7x. Is that what it was in the middle? Yep, it was. Seth, you with me? Yeah. Okay. All right, so that's your check. Or you could multiply it all out if you want, like I said. All right, let's look at the next one. 42, there's a lot of things that go into 42. I have 1 times 42. 2 times 21. Does 3 go into 42? Check. I've run in the calculator, do 42 divided by 3. See if 3 goes into it. Because if you don't know, this is how you have to do it. 3 times 14, good. Does 4 go into 42? Does 4 times something give me 42? Do 42 divided by 4 in your calculator. Nope, 4 does not go into 42. Good. Does 5 go into 42? Yeah. Does 6 go into 42? Yeah. 6 does. 6 times 7 and also 7 times 6. We just repeated ourselves so we know we're done. Now I want to know, we got to do our first term. What times what gives me x squared? That's going to be x times x. 42, I want to know which one of these combinations is going to either add or subtract to give me 17. This time it'll be adding to give me 17. Which one are going to add to give me 17? 3 and 14. And that's easy when you have your list here to look. If you don't have your list, then it's harder to do. So I'm going to put 3 here and 14 here. And I'm only needing to check my middle term, so I'm going to do that little smile, big smile. Negative 3 times x is negative 3x. Negative 14 times x is negative 14x. combine those, and I'm going to get a negative 17x in my middle, and that's what I have up there, so I know it's right. All right, the next one, the signs were different. I have my signs in there. What multiplies to give me g squared is g times g. I'm going to make my factor chart over here. 1 times 27. 2 does not go into it. Does 3 go into 27? Yep, 3 times what is 27? 9. Does 4 go into 27? No. Does 5 go in? Does 6 go in? Does 7 go in?
Wait,
No. Does 8 go in? Does 9? Yep. 9 times 3. So that, I know I repeated myself, so that's all the things that go into 27. So now I want a 6 in the middle. The only choice is 1 times 27 or 3 times 9. So what's it going to be to give me a 6? It's got to be 3 and 9, right? So which one is going to be the positive? Which one is going to be the negative? I want a positive 6g in the middle. So that means in order for it to be a positive, when I combine these, the 9 should be positive, the 3 should be negative. Let's see if I guessed right. If you get it wrong, if you get the same number and a different sign, that means you just switch the signs. Yes?
Does the order of the signs matter?
It doesn't matter, no. No, I could have had, as long as it goes with the number, the right number. The order doesn't matter. I could have had the plus here, the minus here. So let's do a little smile. 9 times g is positive 9g. Negative 3 times g is negative 3g. 9g minus 3g is 6g is what I wanted in the middle. So I got that right. All right, let's see. Next row. How about this one? Let me see. Who can I ask? Lexi. Sign same or different here, Lex? This plus sign means they are the same. I look over here. This is a negative. So are they both going to be pluses or both going to be minuses? Who can tell me? Both pluses, both minuses. What do you think, Miles? Now I got to look here. This is a minus. These mean signs are the same. That's a minus. That means they're both going to be minuses. All right. Maddie, what's the first? What goes in the first position here? X, good, times X. All right. All the things that multiply to give me 15. Let's see, Rayona, what are all the things that multiply to give me 15? 1 times. No, 2 doesn't go into it. And what, does 4 go into it? Does 5 go into it? There we go. All right, so I want to know what gives me a 9 in the middle. Is 1 and 15 going to give me a 9? If I add or subtract 1 and 15? Is 3 and 5 going to give me a 9? So did we do something wrong? That's all the choices. I didn't do it. We didn't do anything wrong. This one can't be factored. Every once in a while, they'll give you one that is called, it's unfactorable. There's a name for it, and it's called prime. If something is prime, it cannot be factored. Okay? You have to know that vocabulary word. And it'll sneak up every once in a while. On the Regents, it'll say, you know, that'll be like a multiple choice answer. All right, next one. Sign same or different this time. Seth, what does this minus sign mean? Same or different? Different. Good. Plus minus. Amelia, what goes in the first position? X times X, right? All right, let's see. Lexi, all the things that multiply to 18. Go. 1 times 18. 2 times what, Lex? 9. Does 3 go into 18? 3 times what? Good. There you go. How about 4? Does 4 go into 18? No. Does 5 go into 18? Does 6? Yeah. 6 times 3. And are we done? Yeah, there's nothing else. Okay. Now I want to get a negative 3 in the middle. So I want to know which adds or subtracts. This time it's going to be subtracts. It's going to be 6 and 3. I want a negative 3 in the middle, so that means my bigger one is going to have to be negative. Negative 6, positive 3. Now again, if you get the signs wrong, then you just switch the signs. If you have the same number but different signs. Here are 3 times x is 3x. Negative 6 times x is negative 6x. Add those together and you're going to get a negative 3x. That's what I wanted in the middle. Okay, I want you guys to try number 6 on your own. You don't have to make your factor chart because it's already there. 18 is the same one. So go ahead and try that one on your own. I'll tell you signs are different. Okay. Yeah, I will. Thank you. Okay, how does everybody do on this one? I have y. Which one of these gives me a negative 7 in the middle? 2 and 9. Very good. I want a negative 7, so which one's going to be negative, my 2 or my 9? Now here, to get a negative 7 when I add them, I'm going to get 9 here, 2 here. When I check it, little smile gives me a positive 2y. Big smile gives me a negative 9y. When I add them together, I get a negative 7y in the middle. Okay. The next one has to do with a rectangle. So when you factor, the Regents loves to put factoring in rectangles. Okay? And what they say is when you factor this, one of your factors will be the length and the other one will be the width. Okay? Because when I multiply 2 binomials together, don't I get a trinomial? So they're saying one of those, when you factor it, one of them is going to be the length, one's going to be the width. So didn't we already factor this up here? It's the same as this problem right here, correct? So I know what the factors are. They're x plus 3. I'll just rewrite the problem here. X squared minus 3x minus 18. When I factor it, I got x plus 3 and x minus 6. It doesn't matter which one you put on the length or which one you put on the width, but one of them is going to be the length. I'll make it x plus 3. One of them is going to be the width, x minus 6. So I'm going to put x plus 3 here, x plus 3 here, x minus 6 here. Now they want the perimeter of this rectangle. What does perimeter mean to do? Outside distance means add up all the sides. Remember how I said this old one from middle school, length plus width plus width? You could use that. You won't see that anymore. The Regents does not like that formula. Now that you're older, they want the other formula. Does anybody remember what it was? 2 what? How many L's do I have here? 2 L's. And how many W's? 2 W's. So instead of saying length plus width, we could say 2 times length plus 2 times width. I'm telling you, you will not see this old formula anymore. They want you to use this one. So that's why we have to expose you to it, get you to use it. Okay? Now, are they going to mark you off if you say, oh, I want to do this? I know perimeter means add all sides. I'm just going to add them in a row. No, they won't mark you off. It's just that when you see this formula, you have to recognize that it is the perimeter formula. That's the thing. Okay? So here, this is the old way. The new way would be perimeter equals 2 times the length, which is x plus 3, plus 2 times the width, which is x minus 6. Then they want you to distribute both of those. So when I distribute it, I get p equals 2x plus 6 plus 2x minus 12. And then what's my last thing? What do I have to do? Am I done there? Combine like terms. Very good, Erin. So when I add my 2 x's together, I get 4x. When I add my plus 6 and minus 12 together, I get minus 6. Well, I mean, really, it does look like a lot of work because we used a formula and we plugged in. In your head, could you have just gone, oh, I got 1, 2, 3, 4 x's here? Yeah. You could have just done it like that. The problem is, remember, the Regents, they want work shown. They'll give you half a page to do this problem. That means they want you to fill up that half page, right? So you got to write a sentence. The perimeter is 4x minus 6. Okay? All right, one more page and we're done. Now, there's a pattern on this one. We're going to do all these, girls. We're going to do all these, and then we're going to discover what the pattern is. All right? Now, these are all factoring, trinomial factors, so we're going to use 2 parentheses. So go ahead and put 2 parentheses on each of them. All right. So again, let's look at these first 3. Does this mean, look at the last sign, is it same or different? What does that plus mean? Same or different? Same. Now, I look at the first sign, it's plus. That means they're both going to be plus. All right, Seth, what goes in the first position? I want y squared, so what goes in the first position? Well, y times y. All right, now, we got to look at our last position. I have to list out all the things that multiply to give me 144. I could go ahead and do that, but last class somebody guessed. Were you going to guess? Oh, you got to guess? 12? It is 12. Good. 12 times 12 is 144. And if I do my little smile, big smile, I get 12y here, 12y here. Add them together, I get 24y is what I wanted, so I know that's right. All right, let's see. Maddie, is this going to be same or different here? Same. Then I look at this side, it's negative, Maddie, so they're both going to be what? Negative, good. X, X. Now, we don't have to list all of them out all the time. 4 we could do in our head. What multiplies to 4? 2 times 2 or 1 times 4. What's going to give me a negative 4 in the middle? 1 times 4 or 2 times 2. What is going to give me the 4 in the middle? 2 and 2. So if I check it, negative 2x on my little smile, negative 2x on my big smile. When I add them together, I get, combining my like terms, I get a negative 4x. All right, let's try the next one. Signs same or different, Miles? Thank you, Miles. Same. It's okay. All right. Now, Miles, how about this one? If I look at the first sign, Miles, it's negative. Does that mean they're both going to be pluses or both going to be minuses? Very good. All right. So I have y times y. What multiplies to give me 49? There's really only 2 things. 1 times 49 or 7 times 7. All right. So it's got to be 7 times 7, right? Let's check it, see if it works. It does not work. Very good. Negative 7y. Negative 7y gives me a negative 14y. That doesn't work. So would 1 and 49 work? No. So what is this called? Very good. This is prime. So cross it out and write prime. Cannot be factored. Very good, Seth. This is like the same thing as number 1, except now signs are the same, right, Seth? Signs are same. Are they going to be both pluses or both minuses this time? Good. And Seth was right. They're both going to be 12s again. 12, 12. So when I do this, I'm going to get a negative 12y and another negative 12y. When I combine those like terms, I get a negative 24y, which matches there. Lexi, you're next. You're up. Signs same or different, Lex? They're the same. Good. And very good, both pluses. Now, this is a little tricky here. It's x to the 4th. It's not going to be x and x anymore. It's going to be what? Very good. X squared, x squared. Now who can just guess what the numbers are going to be? 6 and 6. Good. 6x squared, 6x squared gives me 12x squared. And that one worked. All right. You guys are like guessing really well here. Aaron, is this going to be same or different? Yes. Same? And are they going to be both pluses or both minuses? Good. X plus, X plus. Aaron, can you tell me the final answer? What's going to multiply to 64 that's going to give you a 16 in the middle? Can you guess it? It's going to be 8 and 8. Now, how come we can start guessing these? Is it? Yeah. What did we just do last unit? What are these all called? Yes, very good. Aren't all those, is it 144, 4, 36, 64, even 49, even though that one didn't work? Aren't these all perfect squares? So these are called, the name of these, we should have put it on the top here. These are all called perfect square trinomials. And when you factor perfect square trinomials, your answers, when you factor them, your answers both what? Don't they both match? So when they both match, you can write them only one time, and this is what the Regents does. Instead of saying, I'll let you copy that, and then we're going to rewrite these. We're going to go back up, and we're going to rewrite them all. Lexi, you staying with me? You are? Okay. Okay, so when they both match, the Regents writes them like this. Instead of saying the answer here is y plus 12, y plus 12, in your multiple choice answer bank, they'll write y plus 12 squared. So you got to know that it means the same thing. Here they'll write x minus 2 times x minus 2 is x minus 2 squared. Here they would write y minus 12 squared. Here, x squared plus 6 squared. And here, x plus 8 squared. They write it just one time with the square. It means the same thing. I've seen that more and more over the years with this new Common Core exam. They like writing it, they like those perfect square trinomials, and they don't write them the old-fashioned way. They write them this way. Okay.